In this from Metal, what we are doing is we are firing ping tests from Metal towards VNF.
Hello, we're back. Joining me now, Amar and Vivek from Aarna Networks, in theory. Are you guys there? Yeah, how you two doing?
Right?
Good, good. How are you?
I can see you. I'm doing good. Yeah. So what have you got for us today? What are you going to be telling us about?
Today we are going to be talking about how to orchestrate edge environments in an Equinix data center and then connect it to multiple clouds. Okay, we can go to the next slide. In terms of the agenda, we are going to talk about the market motivation, the problem statement. Then we are going to go into the solution, which is Aarna Edge Services. We'll give a little bit of a technical overview and then end with a demo. All right, next one. So what is the market motivation? The market motivation is we are seeing data center space growing. And the rate of growth is 7.5%. 2022, a lot of industries slowed down, but not data centers. Furthermore, we are seeing, according to Gartner, that the amount of infrastructure available in data centers as a service is going to grow from 10% to 40%. This is just an astronomical jump. And what's even more astounding is that the automation of this infrastructure as a service will jump from 20% to 70% from 2021 to 2025, again, according to Gartner. So these are some amazing, massive changes going on in the industry. With that, we can go to the next slide. And we are seeing this. We are seeing this play out in front of our very eyes. If you look at an Equinix data center, you have multiple compute options, IaaS, Equinix Metal, of course, but you have others as well, AWS Outpost, ZenLayer, HP GreenLake, storage, a number of Equinix Metal partners, Pure Storage, Dell Apex, Seagate Live, NetApp, number of Kubernetes Equinix Metal partners, and same thing on networking, you have Equinix Network Edge, Equinix Fabric, and some other folks as well. So what Gartner is predicting, we are seeing in front of our very eyes. So what is the problem statement? The problem statement is if the data center is moving to IaaS, then why is deploying topologies so difficult? So just to give you an example, we had one customer who came to us and said, you know what, it takes us 9 months to roll out a new application in the data center. You know, we have to buy servers, cable them up, all kinds of complications. With IaaS, we would like Aarna to help them cut that time from 9 months to 1 month. And we were really puzzled. We were like, why are you thinking 1 month? It should be 1 hour at the maximum. But the fact is deploying topologies is very difficult. And once you do deploy these topologies, deploying applications on top, which are hybrid and multi-cloud. By hybrid, we mean that they span private and public. So for example, the Equinix environment and public clouds, and they also span multiple public clouds. Why is deploying these applications so painful? So we can go to the next one. And the solution to that is our product, Aarna Edge Services. Excuse me, Aarna Edge Services is a SaaS platform for deployment and orchestration and management of edge infrastructure, applications, and network services. And we are focusing on the cloud edge. You can call it the new middle mile, or simply put, the data center. And you can interact with AES through APIs or GUI. And this is what we'll see a demo of today. So obviously, we have a lot of ambitious plans. But for now, what can AES 1.0 do? That's probably the question in your mind. So AES 1.0 supports 3 products within the Equinix data center: Equinix Metal, Equinix Network Edge, Equinix Fabric, and public cloud resources such as Azure Express Route, AWS Direct Connect coming soon. And once you deploy this infrastructure, you can roll out applications such as machine learning, 5G, IoT, with more to come. So the use cases for AES 1.0 are first, you can deploy and manage Equinix metal environments or metal partners and connect them to the public cloud in less than 40 minutes. And what's even more interesting is that this connection is then fully dynamic. So you can tear it down, you can optimize it, which using manual mechanisms, it generally ends up being static. You can deploy and manage automated public cloud connectivity from your data center private environment, again, fully dynamic. And last but not the least, you can deploy and manage very sophisticated cloud edge solutions with Equinix digital products, for example, computer vision, NVIDIA Metropolis, or generative AI, open source models such as Meta's LLM Llama or Databricks Dolly, NVIDIA Foundation model, with dedicated connectivity to your SD-WAN environment so you can do training. Next one. All right, so this is the last sort of non-technical slide, and then Vivek will get into the technology. We are in collecting a private beta interest list, and the slots are limited. Please contact us if you'd like to be on it. With that, I'll hand it over to Vivek.
Thank you, Amar. So let's talk a little bit about what is this AES technology, and then I will walk you through an use case which involves bringing up infrastructure at Equinix edge, and then creating a public cloud connectivity automation. So AES multi-cloud domain orchestrator components has got an built-in orchestrator which can orchestrate infrastructure as well as application workloads. And it comes with a controller design studio. We call it a CDS, which is an LCM, I mean lifecycle management component responsible for executing southbound API or Terraform plans or Ansible or netconf, whatever it is required to configure the infrastructure. And it also comes with a graph inventory database, automatically discovers your entire infrastructure plus application stack, and then renders the end-to-end network service topology as well. And it's completely GitOps driven, and one can even execute any workflow or API calls through a GitOps driven CI/CD pipeline as well. And it has a web-based user interface which allows you to design a network service topology, which we will be seeing it soon. The entire component is cloud native, and it is AES entire platform is available over Equinix Metal. So let's think about an use case wherein your DevOps team or the solutions architect team wanting to bring up infrastructure across multiple edge locations, and then connect those infrastructure and application components to various public cloud infrastructure. Isn't it complex? It is, right? In a traditional approach, what would take is like it would take close to a week or two to even deploy the infrastructure at the edge location, and then making a private connectivity towards public clouds such as Azure or AWS would take a couple of weeks. So with AES platform, one can automate and repeat these deployments or network services very well within an hour, actually. So that's what the demo we are going to see. And let me just take you to the pre-recorded video. The step one is log into our AES portal and then input the domain access token. When we say domain, Equinix Fabric, Equinix Metal or the public cloud. Access token should be given as an input. You can use these tokens or generate these tokens from these appropriate portals or infrastructure portals, and then make these tokens time bound. You can delete it once the network service is provisioned, or you can input these tokens as part of your service orchestration workflow as well. So log into this and then input Azure, which is your service principal account details. Similarly for the network edge or fabric account details. And then the metal. So basically what we do is we have to input all these domain access credentials, or not the credentials, it's an access token. And all these access tokens are time bound. Step 2 is using AES Service Design Studio to pick up or select the public cloud regions and the edge data centers where you would want to deploy a metal or the network edge, and then configure the end-to-end connectivity as well. So basically, this is a design part of our platform. So you log into the UI, and then you create a logical name for the topology, and you pick a network or edge or Equinix data center location, and then select a cloud service provider. In this demo, we would be covering Azure. So in this demo, what we did is we are selecting the edge data center as Dallas and the public cloud as Silicon Valley, West US. Okay, then what we do is, like, users should be able to input the Equinix Metal compute related attributes. Select the flavor, and what is the VLAN that you would like to provision, and what are the subnets that should be assigned. Basically everything about this network metal servers, and then you design the virtual network device. And in this case, we are going to use C8000B as a virtual network device, and it's supposed to bring your own license key. So you will have to input your license key. So it automatically, takes all the access control list and SSH users and SSH key generation, and even the local ASN number for the network edge device. At this point, we did metal and network edge. Now, the next step is to configure the Azure Express route circuit, which would be deployed at Silicon Valley site. Basically, this involves selecting the bandwidth and then configuring your primary and secondary IP prefixes, which should be /30 as mandated by Azure. Then what you do is, like, you configure the connectivity between Equinix Metal and network edge, and then the Azure Express route. Basically, you select those bandwidth for these fabric connections. And what we did so far is the design. So we did not provision anything. So AES did not deploy any of these resources, but it created a service template wherein Azure Express circuit will be provisioned at Silicon Valley, network edge, and metal will be provisioned at Equinix Dallas data center. So now what we are going to do is we are going to trigger the service deployment, basically to execute all the southbound API calls to bring up or stand up these resources, and then configure the L2 connectivity, the fabric connections, and then the L3 configurations. So basically, once you get the provisioning and it starts executing all the southbound API interfaces towards each domain. And here what you see is an Azure Express route got provision, but the provision provider status is still showing it as not provision. The reason is we have not yet configured the L2 connectivity from the Equinix side. So now it will stand up the VNF device, and then the fabric connections towards Azure, fabric connections towards Metal, everything will get automatically provisioned based on the service intent. So also it fires all the L3 configurations based on your service intent. So basically to configure the network interfaces within the VNF towards Azure, and then BGP, and the network interfaces towards Equinix Metal, and configuring those interfaces at Metal so that you should be able to get the end-to-end connectivity from Metal to Azure. Once these L3 configurations are done, then it fires an discovery of the end-to-end topology, because from the runtime data, what it does is it makes those API calls and then discovers the entire set of devices and how these devices are interconnected, and all the runtime parameters getting discovered and stored inside AES inventory. So basically, it completed the deployment. So now what we will do is we will verify the status of Azure. In this case, Azure, you can see the provider status has become provisioned, because AES automatically configured those L2 connectivity from the network edge device towards Azure, towards this Azure Express route. So in this, you can see the email notifications, which confirms this standing up of this network edge devices and the fabric connections, everything. You can see this, the fabric connection is, source is DA, that's where our network edge device is running. And then the destination is Silicon Valley, which is the Azure Express route, US West region. So basically, what this inventory diagram shows is within the portal is what are the runtime parameters for the Metal, network edge, and how the fabric connection from the network edge towards Azure. All these parameters one should be able to view it. This is nothing but the circuit, we call it. So you can see this network edge device and the local ASN number, and then the primary connection, because in this service design, we did only the no HA, I mean, a single connection towards Azure, just for this demo. And you can see the Azure side, automatically the resources are getting discovered, and what is the interface name, what are the IP addresses assigned, and what is the local ASN of this express route, everything getting discovered automatically. So this completes. Then what we will do is let us log into this network edge device to see the interface configurations towards Metal and then towards Azure. You can see towards Metal is 168.0.14.14, and then the Azure side is 23.421. And then you can also see the BGP automatically configured between the VNF and the Azure Express route. You can see the neighbor as 42.2, because /30 subnet, automatically the second IP is picked up by or assigned by Azure Express route automatically. Now what we will do is we will try to see the interface configurations at the Metal side, and here we use VLAN as 130. The bonded interface will have an IP subnet automatically assigned. It's 168.0.16. And then the IP route also automatically configures towards your express route as well, which is the 4230 subnet. So now we will run some diagnostic tests from AES. Currently, it is through REST API interfaces, but we have a roadmap item to bring it under within the AES UI, so that anyone should be able to trigger these diagnostic tests and running a ping test from metal servers to VNF or to Azure Express route on the internet. We'll also see the latency numbers now. In this from metal, what we are doing is we are firing on ping tests from on the metal towards VNF. These VNF interfaces will reach very well within a millisecond. The reason is metal as well as network edge devices are running at the same DC location, the Dallas. So that's why you see this ping test showing a sub-milliseconds, okay, less than 1 milliseconds. But when we execute the ping test towards Azure, you will see the latency of close to 30 milliseconds, because Azure Express route is deployed at Silicon Valley, West US region. So that's why you see this close to 30 milliseconds as a latency. When you ping an internet, which is a Google DNS server, you can see the latency is very well within a millisecond from the metal server, which essentially means a metal should be able to reach an internet. Okay, so the next step is, how do we tear down this, right? So it's just not the deploying, right? Think about it from a DevOps point of view, right? Or from a solutions team. You want to stand up these infrastructures across multiple different edge locations, and then run certain workloads or certain tests, and then tear it down, right? So even the destroying is very critical, because you can't stand up these resources when you are doing testing from a DevOps environment, right? So that's where the destroy service workflow comes in. This what we do is, whatever topology that we deploy, then we are going to destroy the same, and it will get destroyed in few minutes actually, because deploy takes time. The reason is standing up metal, and the standing up VNF is a bit expensive actually. It takes maybe close to 20 to 15 minutes for a VNF to come up. Metal comes up very well within 10 minutes, I would say. All right, so here what it does is automatically it will identify the sequence or the order at which in which it should start destroying those resources at each domain. Basically removing the fabric connections, and then deleting the VNF, deleting metal, and then deleting the Azure Express route. The order is automatically maintained by AES. If you have a complex infrastructure where it spans across multiple different edge locations and multiple different public cloud connectivity, AES knows how to order these transactions and then clean up these resources. So this pretty much completes our demo, and you can see that email confirming all the resources which we deployed got destroyed automatically by AES. So these are the email confirmations. So this completes the demo, and we can open up for questions.
Cool. That was really, really neat. I really like the part where you remember to clean things up at the end, because most people don't talk about the cleanup when they're doing presentations like this. So it was nice to see that consideration. I do have a couple questions for you.
Yeah.
Let's see. What do we got? We'll make sure we got about 5 minutes. All right. So one of the things you did in there was actually, first I should ask, where does the AES platform live? Is that something you guys are going to run? It's a cloud service, or is that something I install and subscribe to? How does that work?
It is going to be over Equinix Metal. It is.
Okay. Yeah. All right.
Today.
Cool.
Yeah.
And we run it.
You'll run
it's
it,
a
yeah.
SaaS service, so
Yeah,
it's
perfect.
fully
Yeah.
managed.
Both
it
are
just
great answers.
happens to be on metal.
That's what I was hoping for. So with that, you were asking for a lot of credentials for logging into the Azure, into my network metal, my Equinix metal and network edge instances. How are you going to be storing all that stuff securely?
Right. So if you look at it from the first part of the demo, right? So user has to input today.
Mm-hmm.
These credentials are securely stored within the HashiCorp vault
Okay.
and tightly controlled through RBAC policies, wherein none of our engineers can access those. Plus, these tokens, what we advise our customers is to generate it as a time-bound tokens.
Right. Yeah.
Basically, what happens is like we don't need AES doesn't need these tokens post deployment actually. So as part of the deployment action or the workflow, what one can do is they can automatically create a policy to generate this for a time bound, maybe for an hour or two, based on the complexity of your node topology, and then AES uses it and then it discards it. It doesn't store it permanently.
Cool. So you've got Azure shown. Are you planning connectivity to any other service providers?
Yes.
Yes. Okay.
Right. Yes, of course.
More details to come. All right.
Yeah, I think the usual suspects. I think
Yeah.
AWS, Google, Oracle are high on the list.
Sure. Okay.
Exactly. Yeah.
All right. And you showed kind of the Dallas connecting to other resources also in that region. Are there any going to restrictions between what endpoints I can connect to what endpoints, like region to regions or anything like that?
So basically, it all depends on your network service design, right? So what we do is, you go and pick up a edge location, and then design a service with metal, but we do validate it whether that particular edge location supports Equinix metal, because Equinix metal is not supported in every
Right.
single HDC, right? It has got a dependency. So what we do is we do discover these resources and we do validate it whether the service topology is valid.
So
As
like
part
as
of
long as it's valid, I should expect that it would be available.
exactly.
Yeah. Okay.
Yeah, even for the
Perfect.
network edge,
Yeah.
it's the same.
Yeah.
Even the public cloud connectivity is the same, because not all regions of Azure provides a private connectivity.
Right.
So we do have these validation checks because we discover all these connectivity and provided informations within the AES database.
All right. One last thing I really wanted to ask. There was a point where you had the template all ready and designed, but you hadn't provisioned it. Is there going to maybe be an export button at that point where I can see like the code or all the details there? Because that's the most interesting thing to me, to either review or use for just using your tool as a builder.
Yeah, I think we have a lot of items on our roadmap. One is configuration as data. So being able to import or export, that's high on the list.
Cool.
And also another aspect is FinOps. So before you hit the deploy button, you probably want to know how much it'll cost you.
Exactly.
So all these are things that, but the most important aspect is to be customer driven. So as we start engaging with customers and building that up, we'll hopefully get steered in the direction that they think is important.
Cool. Well, that's all the time we have. I want to thank you, Amar and Vivek. We will see you around. And at this point, I'm going to say hello to Daniel Mangum from Goliath, in theory.
Thank you, Chris.
Oh,
Thanks.
thank you.
Thank you so much.
Thank you.